There are some common data engineering tasks that are part of building any data warehouse, and the modern lake houses are no different. This video continues video series dedicated to learning Microsoft Fabric, which allows you to build your lakehouse on cloud. Um, in the past few videos, we have explored basics of basics of Lakehouse. We learned navigating OneLake hub, and we learned managing notebooks. Today we are going to focus on ingestion questions. So there are a number of decisions that needs to be taken when you are building your ingestion pipelines. For example, you have to decide what tools to use to bring your data. You also have to decide whether or not you need to have intermediate stage or landing zone for your data. Um, so we are going to discuss these architectural questions or patterns. I'm also going to show how to build pipelines to bring the data. Join me to learn more on that. Hello friends, welcome to my channel. My name is Fikrat, and here's a quick preview of what we're going to cover today. We'll start with the discussion of data architecture aspects of Lakehouse ingestion. I'll explain importance of landing zone for certain data sources. Then we'll explore different ingestion tools or methods that are available in Fabric for Lakehouse ingestion. So we'll take a look at Dataflow Gen2, then we'll explore data pipeline. Finally, we'll also build ingestion pipeline from landing zone to bronze using Spark notebook. So we'll first take a look at SparkSQL methods, and then we'll explore PySpark methods. To wrap up this discussion, I am also going to show how you can use OneLake shortcuts for direct ingestion from data lake storage. Quick reminder for those who are new to my channel, please take a moment and subscribe so that you could always be up to date with my latest videos. Okay, so let's get started. Let's have a quick discussion around architectural aspects of Lakehouse ingestion. In the introductory video for Synapse Engineering Service, I mentioned that medallion architecture is a recommended architecture when you build your data zones within a Lakehouse. Just quick reminder, so in that architecture, we are talking about 3 zones. So that's bronze zones that contains your data with minimal or no transformations. And then we mentioned about silver zone, which contains your transform and enriched data. And finally, we also mentioned gold zone, where you have curated, clean data. Maybe you have dimensional models there. So that's the data that's ready for consumption. Now, how do you ingest data from external systems into Lakehouse? Uh, for certain data sources, like databases, I think it makes sense to have direct ingestion, like what you can see here, because we are talking about structured data in the source. However, for some other data sources, it makes sense to consider stage ingestion. That's what I am displaying here. So with that, in this architecture, you first drop your files in the intermediary zone called landing zone. And from there, Databricks or Fabric can easily ingest the data to bronze zone. So this architecture will require a little extra space, of course, because data will be sitting in few places. However, its advantage of this approach is that you may have your data in original shape. So for example, if you are bringing JSON files or CSV files, you may just keep there and without worrying about building your pipeline. And this, you can also dedicate some space there for archiving purposes. So to recap, stage ingestion makes more sense for file data sources, flat file data sources, whereas direct ingestion is probably better for ingestion from databases. Okay, so let's jump into the demo. Okay, I am in Microsoft Fabric and I navigated to Lakehouse that I created earlier. Uh, the first demo that I'm going to build is going to bring data from Azure SQL database to Lakehouse table. So it's going to be direct ingestion. So I'm going to navigate to get data and from here to select to Gen2, so Dataflow Gen2. And that opens me, that creates data flow, brand new data flow, and presents design canvas for data flow. Um, if you are new for data flow and would like to learn more about that, I have few other videos where I explore transformations available in data flow. For now, I'll just navigate to get data menu and select SQL database and will enter my connection details. Okay, so Fabric has recognized this connections stream because I have used this connection before. And all I need to do is hit next. And that will present me a table selection screen. So I'm going to select a couple of tables here, address and the customer, and hit create. So advantage of this method, of this tool is that, of course, you can apply some in-fly or on-fly transformation as you bring data, not just bring data as is if needed. But as I mentioned, it's recommended practice to bring your data as is and then apply your transformation in Lakehouse. So my data sources have been added to my data flow, and if I navigate to destination, you can see that destination have been automatically added, so which makes job easy. So all I need from here is to hit publish button. So my data flow has been published successfully. Now I can run. So now I can refresh this data flow. So just to remind, refresh means actual execution of this data flow. And this should bring data to my lakehouse. So as you can see, refresh process in progress, and I'll fast forward and navigate to lakehouse. So my data flow refresh process has completed. Now I'm gonna refresh my table list, and I guess as you can see, we have new tables appeared here. As a second demo, I'm going to build a pipeline that will bring data, flat files from my data lake storage account. And my target is going to be unmanaged section of Lakehouse. So on the files, I created landing folder, and that's where I am intending to bring my files in. Just like with the previous exercise, I'm gonna head up to get data menu. However, in this case, I'm gonna use new data pipeline. Of course, files can be brought using new Dataflow Gen2 option as well, but I'm gonna select this data pipeline option just to bring a different perspective. That creates a pipeline and opens a copy wizard. Um, Copy wizard is a great tool to start learning data pipelines if you are new to new data pipelines. I have described it in one of my past videos. I also had a number of other videos that describe how you can add different controls and build sophisticated data pipelines. So I would suggest to take a look if you are interested in more in data pipelines. For now, though, I'm gonna select navigate to the bottom of the screen and select data lake storage. We'll confirm. Next, I'm gonna select connection because I already created a connection pointing to that data lake storage. If you don't have connection, you have to select create new connection option. I'm going to select my folder. So if I expand this, you can see that I have a few CSV files underneath. So I'm going to select my folder and we'll select schema agnostic option, so which tells Fabric to copy files as is, just like physical files, without worrying about the data format. So the next step in this wizard is to select destination. Um, as you can see, we have two options, existing lakehouse and create new lakehouse. In this case, I am gonna write to learning LH lakehouse, which is pre-selected. So that's one nice thing that Fabric offers when you start building pipeline from Lakehouse. So as you can see that your Lakehouse already pre-selected. I'm gonna select hit next. And here we have two options, tables and the files. The tables option is disabled because I have selected binary option. And with files option, I have to select destination folder. So I'm gonna hit browse, and from here select my folder and confirm my settings. So here's I have another drop down that's important. So it says copy behavior. And if I open it, we have two options, flatten hierarchy and preserve hierarchy. If you have file source that's hierarchical, so for example, if you have nested folders in your data lake storage, then you may choose preserve hierarchy. This option will ensure that your destination folder hierarchy resembles your source hierarchy. Another option, flatten hierarchy, will ensure that all the files are copied into the same folder with auto-generated names. So for my purpose, I'm going to select preserve hierarchy. and confirm. I'll leave file format as binary, confirm. And in the last window of dialog, I am proposed to start pipeline immediately. If you don't want your pipeline to be executed immediately, then you can uncheck that. For now, I'm just gonna leave this and confirm. So this creates a pipeline with single copy activity and immediately start execution. It will take few seconds to copy the file. So the execution now is complete. Now I'm gonna navigate to Lakehouse. I'll refresh my landing folder, and then all my files have arrived. So quick recap before we move to my third demo. So we have built two pipelines here using different technologies. In the first case, we have built direct pipelines, which uh, populated Delta Lake tables, so the Lakehouse tables. And the second pipeline was a staged pipeline, which brought data to my landing folder. Now I'm gonna go navigate to Notebook and build pipeline to bring data from landing to Lakehouse. So I'll open my notebook. I'm gonna share link for that notebook in case you want to repeat this experiment. Okay, so let me hide my panel and zoom in. So in this notebook, I am exploring two methods, so two high-level methods. First will be using Spark SQL for end-to-end ingestion to Lakehouse, and then we'll explore PySpark methods. So my first cell, let me zoom in. So my first cell have select statement. However, it reads from CSV dot file location. So I have included my file location or file path with in backtick, so you can see backtick. So this allows you to query pretty much any kind of file formats. So in this case, it's CSV, but if you have Parquet files, you can easily browse these files using Parquet keywords here. Same applies to Delta, so you can use Delta to read from Delta Lake. So this is very easy and convenient. So let me run this. Okay, so few comments about the data that we have inside this file. First of all, column names are incorrect, so that will need to be renamed. So that's auto-generated column names. And then we can see that column headers start at line 5. So I need to remove all these first 5 lines. So let me scroll to the next cell where I have this select statement which renames my columns. So as you can see, we have C0 renamed to date and so on and so forth. And here I have some extra constructions. So basically I am applying filters. which removes all of the rows with this column being empty. And I also remove any columns where, so basically column headers, because I don't need them inside this data frame. One thing to notice here is temporary view. So this is something that we haven't talked about. So temporary views allows you to create views which will be lived uh, within your session. So you create your notebook. And once you create this temporary view, it will be alive until your session ends. So next time, as soon as your cluster shut down, this view will be gone. Um, Temporary views are a very good tool if you are building multi-step transformation. So this allows you to build different steps, and so this allows you to build different steps based using different temporary views. So that makes your code simpler and easily readable. So that's a great technique that I'll be using in future videos. Okay, so I'm gonna run this cell and create this view. And let's add one more cell here and see how my data looks like um, from this view. So I'm gonna add SQL Magic, and we'll add simple select statement. Okay, so my data looks good. So I have correct column names and I don't have any dirty data in my data frame. So that's good. Okay, now that we learned how to read data from flat files, let's see how we can write the destination. So let me scroll down and to my next cell. Okay, so in my first cell here, in my next cell here, I am showing how to use CTAS technique or CTAS syntax to write in the destination table. So CTAS stands for create table as select. It's common, so well-known technique from traditional SQL. So what this code does, it creates table, sales table using delta format, and then it lists select statements that will need to populate that table. So let me run this cell. Okay, and now we can query this table. So let's see what we've got in this table. So data looks good. Okay, so let's move on to next cell. In the next cell, I am demonstrated different technique to write into target tables. So this could be good if your destination table is already in place, and all you want to do is to append to your destination table. So just to mention quickly here that with the previous approach, so with CTAS approach, my tables will always be overwritten with new data. Whereas in some cases you might want to just to append it to your to the end of your table. So that's in that scenarios insert into syntax could be useful. Okay, now that we learned how to use SQL, Spark SQL for ingesting into Lakehouse, let's take a look at PySpark methods. So my first PySpark cell, is using Spark Read APIs, which I have described in the last video. So it basically has a read method and has saying that it's CSV file, so it specifies format, and then it includes path, so source file path. Okay, and then the next command is just displays the content of that data frame. Okay, so that generates the data frame. With previous case, it requires some massage. So you can see the column names are incorrect. I'm gonna apply some minor transformations to improve that. And my next command applies this transformation. So first I'm applying here filter, which is similar to what I have used for Spark SQL. So nothing fancy. And here I am using select method, which brings all the columns, and I'm using alias method to rename these columns. So let's run this and see the results. Okay, now my data frame looks good. And let's move on to the next cell, which takes care of writing the destination table. So this is so I described write method in the previous video as well. So it's straightforward. So you specify your data frame and then include write, and then include save as table. So that's key method that ensures your data is written to sales table, to your destination Lakehouse table, and then you can also optionally include write method. So in this case, I am telling overwrite to overwrite destination table, which will wipe out any existing data and overwrite it with new data from my data source. Let me run this. And I'll run quick select count statement just to see how many rows I have. Okay, so I have around 400 rows. Now let's explore other destination writing techniques. So this command is similar to the previous one, except I am using append mode here. So difference is that it's instead of overwriting, it will add the data to the end of your table. So that's a useful technique when you are building incremental pipelines. Okay, so it's completed. So let me rerun my select statement again. Now I have twice as much as data I had in this table. Another alternative approach relying on different methods. So it's relying on save method. That's something that I also covered in the past video, but it's very similar to save as table. one difference here is that you have to specify a folder under which this table will go. So just to open here, you can see that all my data tables are located on the tables folder. That's why I have tables. I specified tables here. So if I run it, results will be same. Results will be similar to what my previous cell did. Before I wrap up, I'm gonna demonstrate another technique here, which is using so OneLake shortcuts. So for those who are not familiar with OneLake shortcuts, I have a dedicated video on that. Um, Take a look. Uh, for now, though, I'm just gonna show here the shortcuts that I already created. So this is a shortcut that points to my data lake storage folder, the folders that we use to ingest data from. So if I hit this shortcut, you can see the files underneath that. So good thing is that you can easily ingest any data from shortcuts, just like you would do from local folders or tables. And you can easily get path, so relative path for these files using the techniques I already demonstrated. So I'm gonna hide this and go back to my command. So this command is similar to read commands that I mentioned earlier. What's different is that here I am reading files directly from shortcuts, meaning that files come directly from my data lake storage without being deposited in my lakehouse. Okay, so my data looks good. And of course, I can apply any transformation that's needed and write in the destination using techniques I demonstrated earlier. This concludes today's session. To summarize, we learned the importance of um, staging and the landing zone in Lakehouse. We also learned using different tools and techniques to bring data to Lakehouse. Hope you enjoyed. Thanks for watching, and I'll see you in future videos.